great coffee, Rob. You said you were going to ask me about other theories of cosmology.
Yeah,
We can keep talking about ones that don't use a lambda, ones that don't even use dark energy.
I don't even think you necessarily need dark matter as an element of it.
Okay. And don't even need dark matter.
Yeah.
Some will be niche theories, meaning they just deal with a small part of the universe, such as galaxies or certain stars. Some might be alternative models, and some will be more overreaching than just our universe.
Okay.
When a star like our sun uses up all its fuel, it'll collapse under all the gravitational pressure and become a white dwarf. With this intense pressure, if there is a lot of carbon atoms in the core, those carbon atoms can arrange themselves into a lattice.
Right.
And in 1968, Hugh Van Horn calculated that they might cool down and form diamonds in the core of these dying stars.
Oh, wow.
Yeah, many in the public thought this was way too far out to believe. They might have jokes like, oh, was this inspired by Lucy in the Sky with Diamonds, which was written a year before by the Beatles? But 50 years later, there was experimental evidence that showed that this could happen.
Wow.
There is a white dwarf that is expected to form a diamond core that is named Lucy after the song.
Right.
Emergent gravity says that gravity isn't a fundamental force, but it's something that emerges out of space and time, much like temperature emerges out of the motion of particles. Eric Berlinda developed this theory around 2010. It's a bit of a newcomer, but it's already showing promise at explaining galactic behaviors such as matching rotation speed with the luminosity of galaxies. So we'll keep an eye on it.
Okay.
Beatrice Tinsley worked in theoretical astrophysics and cosmology, especially galaxy evolution. She did research on different types of supernovae, which are exploding stars, and how the explosions add new chemical elements to galaxies. And these fit into her larger idea of galaxy evolution. Stars are born, they manufacture elements, some explode as supernovae, and their material gets recycled into later generations of stars. She ended up being a professor at Yale. That's your alma mater, right, Rob?
Yeah.
Have you heard of plasma theory?
Well, you know.
It tries to explain things like filaments and plasma jets. It says that the structure of the universe came about not only through gravity, but also through electricity.
Yeah.
Stars like our sun are basically big balls of plasma containing a fusion reaction that gives off light and heat.
There's other ones, right? That's what I'm saying. Like, there's all these ones that multiverses, bubble verses.
Okay, well, a bubble verse is just one type of multiverse. Multiverses come out of string theory and other theories that can help explain cosmic inflation. They come from tiny quantum fluctuations and also through other mechanisms that leave a lot of possibilities for universe evolution that can eventually evolve into an entire universe, each with its own laws and constants. Some you're familiar with, like our universe, and some may be totally exotic. Yeah, bubble verses are related. Think of it like the bubbles in your bubble bath. Each time one pops up out of another one, it's similar to that. In fact, it's like a little quantum fluctuation, and one of the bubbles can become new structures and even a universe.
What do you think of the
Holographic
universe?
Well, the holographic principle grew out of black hole physics. The information that's associated with what's inside a black hole can be represented on the two-dimensional surface of its event horizon. The information that is represented on this two-dimensional surface of the event horizon is then projected, and then we see it as a three-dimensional universe. I can see how it might seem a little bit out there, but the mathematics behind it is pretty serious.
Okay.
Yeah, a team at the University of Ottawa had a clever way to remedy the early universe surprises. So they tweaked some early universe assumptions, and it came up with an age of the universe that was nearly double the 13.8 billion years that the standard model gets. And it got some headlines, but it still needs to face the scrutiny of all aspects of cosmology. Another one is quantum gravity theory. That quantum theories help us explain things on the very small scales. That it tries to unify the very small scales of quantum mechanics with the very large scales of general relativity.
Yeah.
One of the big questions in physics is, how could we unify the large numbers that quantum gravity gets for the amount of dark energy in the universe compared to what we observe? And what we observe is closer to what the standard model gets. But if you could bridge that gap, or figure out why they're different, or unify the two, that would be a huge deal. You'd be unifying quantum mechanics with gravity.
Oh, that's interesting.
Yeah. If one of your listeners could get right on that problem and come up with a solid explanation that unifies the two in that way, they would likely win a gold medal.
What's that?
It's the Nobel Prize.
Do you think there's other cosmological theories that should be weighted more than others?
Well, that's interesting that you bring that up. There are different types of software that compare different cosmological models by assigning weights to them. This way, you can see which ones are more probable given the data. Because I've been advocating for a unified ensemble model, I would like to get a bigger collaboration together to reach agreement on what theory should be weighted when looking at this particular part of the universe or at that time in the evolution of the universe. And I think that would be one way that we could possibly make something that is more accurate.
Yeah.
And there's these promising alternative models that do a great job at explaining pulsars. The idea of quark novae suggests that they could create isolated millisecond-long pulsars. And some models even propose asymmetrical mass ejection from proto-white dwarfs that can explain eccentric orbits of these types of pulsars. There's evidence that they emit superpods of X-rays that surf gravity waves. Yeah, they think they've found gravity without mass.
Yes.
You know, we've been considering the anisotropic stress energy tensor in a de Sitter universe with a energy density of dark energy and quintessence fields.
Did they actually use that kind of terminology, or did they?
Yes, they do. It kind of is talking about how the universe's fabric can stretch in different directions and how that affects the energy in the universe, especially when we think about things like dark energy and hypothetical fields.
Oh, yeah.
And doing so in a universe that's not uniform in every direction.
You know, or we don't know if we're measuring the gravity waves perfectly and everything, and we actually can't see way to the end. We can only see a certain distance out. We can't see the whole universe, so we don't know.
Right, even with the James Webb, right?
Right.
All right, well, Brian, that blew my mind as usual. Thanks so much for talking with me, and I will see you soon. Good night.
Oh, thanks for having me. Dark matter, dark energy.
When Hubble found that the universe was expanding,
Hubble couldn't say that it was a bubble expanding, could he?
Oh, when they learn to contain a star and transport it to where they need it to be. Well, if they can reverse the spin of the star,
but then later came along the dark matter idea. They needed it for that,
Yeah.
for dark matter.
I think that was actually invented by Robert Smith.